Alright, so I'm going to make a new solution. Going to be an empty project. And we're going to play like we're grown-ups and actually create things with header files and everything. So I'm going to do new class, or excuse me, I right click on source files, do add new class. It's a C++ class. Why, yes it is. And it's going to have the name point. I know we already did a point in the last one, but we're doing it again. The H file is going to be point.h. The CPP is going to be point.cpp. We did do a constructor, but all we did is have it say creating and then destroying. Yeah, that's all it did. Okay, so it split it up to where we have a constructor over here and a destructor over here, and nothing is declared inline. I'm going to delete point.cpp, if I may, and recreate it so that those things are declared inline. I don't think I deleted it when I do that. Yeah, okay, good. Alright, do that again. Add class, click add, but I want stuff to be inline. Point with a capital P. Point already exists. Do you wish to merge this class into the same file? I guess so. Point.h is not in the project. Would you like to add it? Sure. Alright, so it actually put the constructor and the destructor in the header file. And I'm going to go ahead and do it like that.
How did you do that all again? I'm sorry, I missed that.
Right click, add class. You click add here. There's no choices to choose unless we decide to add something else, a different kind of class. And then we give it a name, point, and then we click inline. Inline is what actually puts the functions in the same file as the header file. So our CPP file, we may not even have one.
What's the name of the base class, or does it have?
No base class. Base class is inheritance. We're not inheriting anything from anybody.
It just gives you the header file. It doesn't actually have
Yeah. Okay, so we're going to make two private things. Private int x, private int y. I'm doing the wrong syntax. I'm doing Java. Private colon int x, int y. Now our constructor is going to take two variables in order to set those variables. It's going to take an x and a y. So we're going to set this x equal to x and this guy's y equal to the y parameter being passed in. The destructor doesn't need to do a darn thing because it's not like we're allocating any RAM or anything like that. We're not opening any files or mallocing anything, so he doesn't need to do anything. We could even delete it. So let's create a file, add new item. It's going to just be a CPP file, source.cpp, that uses the point class. Oh, # include, IOStream, all the goodies.
No, we have to include that.
And we will have to include point.h. You're correct. Alright, got our boilerplate done. I need to include point.h.
Quotes.
And it is quotes around it, that's right. Audio engine endpoint. Cool. Got quotes around it because it's in the same directory as our other stuff. It's not going to search the C library path like it would for IOStream and point, so point.h. Alright, going to create a point. Point P1, it's at location 10, 10. Point P2, so location 0, 0. Point P3, so -2, -2. So they're all in a diagonal line. All right, what did I say that? For those who just got here, we created a point class that looks like this. If you need a copy of this to work on it, let me print it out for you. So this is a header file. Do a new header file. And tack this code in it. All right. Anybody else? Okay. Well, if more than half the class needs it, then why don't we just leave it up?
Yeah, sorry, I was.
No, it's totally cool. Totally cool.
Well, you need a semicolon after point P3, but that's the only semicolon after point P3. I don't know yet. Go ahead and put semicolon after P3 and do a build. Yes.
So we got rid of point.cpp because we don't have an implementation of a point CPP in this. It was trying to mix together our code, our main source code and the class definition. So you can delete that stuff. Yeah. Yeah, yeah. C++, CLI, support this. Still. Okay, just delete everything out of that. In fact, close it and then come over here and remove point.cpp. All right, guys, I probably shouldn't have done it the way I did it. We're giving more than one of us problems. Right click on point CPP, do remove, it'll ask you if you want to delete it. Okay. So by doing it inline, we were all creating .cpp files, and if you put your source code in the CPP, then it was conflicting with what we were defining in the H file. More trouble that you don't have to worry about in Java. Okay. Adrian loves it when I say that. Okay, so here's our code. It makes 3 points. Well and good, but we had decided that the point class was going to do a few things. Right now it's not doing a darn thing. We're just creating it. It's like big whoop. Maybe let's do a print. It'll print the location of the point out. And a distance from another point. Like that. So before we start messing with operator overloading, we're going to do the easy ones. Print is going to print out the points. It's going to print out its X and its Y position. It's the it's the equivalent to Java's toString method. And then distance from point. We want those two. So I'm going to go back to point.h. These are all methods, so I'm going to leave them all public. Print doesn't need to return anything, doesn't need to accept any parameters, so I'm just doing that. And it's going to see out point colon x equals followed by this guy's x followed by a space y equals followed by this arrow y followed by ENDL.
Whenever you're doing that, is it bad to use your accessor methods instead of how you have like this X? Could you do get X instead, or would that not?
Except we haven't created any. But
so
right,
already-
right. There's nothing. Okay, that's cool. Yeah. In your code, when you're inside the object, you can still use your accessors if you want. You can use getX. I forgot to implement them. I got distracted. So
Which one's preferred? You know.
I can't say that one is preferred over the other. It's kind of like you trust yourself inside the object, but you know, to use it in the correct way. There were build errors. The error is probably that it doesn't know what in the world a cout is. That's my guess. Yeah, cout. So we're going to come up here and do a using namespace IOStream in the header file, which is okay. But we also need to, and I'm surprised they didn't do this for us, use that pragma once thing, which guarantees that this header file will only be included once, no matter how many # includes you have.
Is it the hashtag include IOStream?
It's not using namestream. Yeah, it's just include. What am I doing? Okay, there we go.
Or do we need to use a namespace STD?
Only if you want to avoid doing this. If I don't put the using namespace, then I have to preface things with std:. I don't mind doing that.
It's more than I wanna do.
So yeah, I'm gonna go back and add it. Using namespace std. Let's see if he builds. Okay, let's test out our print methods. I'm gonna go back to sort. I'm gonna move print up, and it doesn't change the way it works. I just want it closer to the top because that's where I added my new # include in my using, so I just kind of want it, all the changes we made close together. That's our new function, and you don't have to break it out on 5 lines like that. Eventually I'm going to delete it. So, I mean, not delete it, but delete all the character turns so it's all on one line. Going to go back to source.cpp. Let's print out our 3 points. p1.print, p2.print, p3.print. Now what would be awesome, which we probably aren't going to do, I don't remember how to do it, would be to make it so that we could do this. We would need to overload the stream insertion operator so that we could print them like that. Like I said, I don't know how to do that, so we're not going to. All right, let's run it. All right, it prints our 3 points. All right, now let's implement distance too. So we're going to need the Pythagorean theorem. 0.2's x minus 0.1's x plus 0.2's y minus 0.1's y square rooted. Here's what I want it to look like anyways. Double p1's dot distance to p2. That's how I want it. No. Let's just say d. Distance is equal to p1 dot distance to p2. That's how I want it to work. We haven't implemented that method, so obviously that's not going to work, but that's how I want it to work. So if both of them were at 0, 0, then the distance ought to be 0. Cout d1, d2 distance equals, no, p1, p2 distance equals, and then we'll just output d.
So you guys, I was gonna say,
I know some editors you can like highlight that, right click on it and make it, go make the change in the header file to implement that. I don't see that working. But anyways, we know that the method is going to be called double. It's going to take a point as a parameter. Maybe we'll make it take a reference, so it'll be nice and clean.
so it's gonna take a point.
Gotta take it in, right?
No, the point 2 is a point.
Oh, the object, sorry.
Right. Okay, so I'm going back to point H. It's a double. It's called distance 2, and it takes point ampersand P. Now we need to calculate the distance.
Didn't you have to do that, C++?
Since these are all ints, we could get away with using ints. So the distance is equal to P1's, no, P's x minus this object's x. But let's take the absolute value of it so we don't have to worry about getting the square root of a negative value. And then we're going to tack on the absolute value of p dot y minus y. Then we need to take the square root of it. D is equal to POW D to the power of 0.5. That's just the Pythagorean theorem. It didn't like POW. Okay, it fixed itself. And then I need to return it.
Did you?
One of the things that makes this a little bit different for you Java guys is sometimes you're using an arrow to reference a member of the class, and sometimes you're using a dot. You're using a dot when you have the object itself or a reference to it. You use the arrow like that when you have a pointer to it. And so this keyword in this case is a pointer to the current object. So that's why we're using the arrow. You don't do that in Java. You just use dot everywhere because pointers don't exist. All right, I suppose that's right. The distance from 0, 0 to 10, 10. Let's
5. Shouldn't
let's do 3, 4, 5. So to get that we're going to go back and modify source.cpp so that point 2, so that point 1 is at 3 and 4. Why is that? Because that's the only one that I'm absolutely sure the size is. You know, if the first one is a 3 and the next one's a 4, then the hypotenuse is a 5. Ha! That's not working. Three squared is 9, plus 4 squared, which is 16, is 25. Square root of 25 is 5, so why is that not working? Hey, when I'm happily doing a... Do you see it?
I think it's something to do with your expression, the way you have your expression. Is there any way to make it all one expression?
Yeah, there is, but what I'm going to
I
do...
think we should try to simplify it to where it's just, because it's, yeah, that would probably help.
I'll set a breakpoint on it here because that's what I'm curious about, if this works. So I clicked over here in the border, on the edge, on the boundary. I'm going to go into the debugger, let it run. There were build errors. Uninitialized D used. Oh. Alright. Yeah, I've padded out the expression to 4 lines when it really only had to be 1. Okay, but D1 is 3, that's correct. Between 0 and 3 is 3. D2 is 4, that's correct. I forgot to square them.
That's what it is.
That's what it is. Alrighty. So, D1 times D1 plus D2 times D2. Get rid of my breakpoint. We don't need that anymore. Okay, that worked.
It should be 5, yeah.
Should be 5 exactly if you have the values I have. Just uno momento. Here's our code. This is over in source.cpp.
10 and 0, 0, so just print out 10, right?
No, because 10, 10 is 100 squared plus 100, so it'd be the square root of 200, whatever that is. If you saw it, draw it on the screen. Yeah. If it's 10 this way,
The thing is
if it's 10 that way and it's 10 that way, then this is not going to be 10.
it goes 3 over in the x and it goes 4 up in the y, so it goes.
So it goes to 5, yeah. Okay. Everybody got this working? Whoops.
I guess I just want to see where I did mine wrong. How much of the property I just started with, but I have, isn't it supposed to be this one squared plus that one squared and then take the square root of it, right? That's what I did wrong.
It says distance plus POW. Is that supposed to be distance plus equals? And come to think of it, guys, we don't need to take the absolute value of anything because when we square it, it's going to turn positive. We can simplify our equation a little bit. All right, how are y'all doing back here?
Yep.
Working? Oh, yeah. Pressure's gone. Getting there. I see red underlines. Public needs to be lowercase, smaller than there. And here, make that point dot H. With a closing angle brace in the end. Get rid of that other. And go ahead and add using namespace.
For the point dot H, it's gotta be the equivalence.
Yeah, take the angle braces out entirely. Right, I just had you one, remove that one, but also remove it from the other side. Okay, cool. That's kind of working. Okay, cool. All right, let's overload an operator. Let's check to see if 2 points are the same. Here's what we cannot do. This does not work. In this language, in Java, this is illegal. You can't do this. If P1, well, gotta have the parentheses. P1 is equal to P2, do something. Okay, well that's giving us an error. That's better than what Java does. Java doesn't give us an error, but it doesn't work. What Java is doing is just checking to see if these two objects reside in the same memory. He's making sure that they are the, quote, exact same object, not that their values are the same. You know, not that you have 2 points.
Can we say if point P1 equals point P2?
Exactly, we could do that, but those things are private, so we don't have that access to it out here. But we're going to do that inside of point.h. We're going to make a...
What if you use your accessor methods? Could you?
We could. We never added any accessor methods.
You forget.
That's what he said.
We're being
That's what we're about to do, right?
we're being weird. Not yet. So override operator equal equal in C++. Let's see how to do it. C++, Caltech, they have to know what they're doing. They're pretty smart. That's the assignment operator. I don't want to mess with that. I want to mess with equal equal.
I saw something like this in Python, and it's weird because like you double underscore whatever you want to override. Like this guy created his own string class from it by overriding the str. That was weird. I didn't like it.
Yeah.
Don't mess with things I know.
Okay, that's what our prototype, our header definition is going to look like, except they threw in a whole bunch of consts to make things more complicated.
Care to explain?
I'm going to take away the consts. Okay, this is just our function name. That's our function name right there, operator equal equal. But C++ behind the scenes calls operator equal equal when you use equal equal to compare two objects. So just like we did this, double distance to, and we had a second point here, and we were able to use that point to compare it to the values of this one, we're going to do the same thing. I'm going to also call this point P rather than other. And so it's going to look real easy. If our x is equal to the points x, and our y is equal to that points y, return true. Else return false.
So does the operator not need to take X and
Well,
points?
what operator is doing is we're feeding it like this. Where's my... Oh, we don't have it. Did I put it? No. Okay, fine. We'll put it here. If P1 equals P2, cout P1 equals P2 slash n, else cout P1 does not equal P2, which is very true. At this point, they do not. So when we run it, I'm going to take out these extraneous braces since it's only one line of code. There we go. So if the distance between them was 0, which I could force by making them the same point, I'm going to change both point 1 and point 2 to be 3, 4. Now the distance between them should be 4. 0, the distance between them should be 0, and this if statement should say that they're equal. And it said that they are equal. This is absolutely something you cannot do in Java, and it's one of the cool things about C++ is that you can overload all the operators. You can make multiply do something, you can make it add do something, subtract do something, equal, not equal. You can make the assignment operator do something. You have an insane amount of control over how the class is used and how it can be used. A lot of syntax that Java does not give you. Anybody need point H brought back up? What other operator would it make sense besides comparison? I don't see how you could do less than or greater than.
You could do like if the distance of one of these, or check see which one's distance is greater.
Yeah, from 0, from the origin. Whoops, I didn't mean to do that. I meant to pause it so I could come back there and check yours. Just get lost. Okay. What am I doing? It's a little orange button, so I'm...
Yes, I understand why. X is just because we don't have anything else.
Because there are no other x's for it to possibly be. I could go ahead and do that, this arrow x and this arrow y, like that.
Okay, how does it know it's adding it? Sorry.
I wish I could get these things up at the... I don't want to shrink it so much you can't see it, but... Okay, so point 3, I'm going to define as 0, 0. I'm changing the declaration of point 3, P3 to be 0, 0. But now I'm going to do this. P3 plus equals P1. So since we have operator plus equals over here, the compiler is letting us use plus equals in this syntax. whereas it would not otherwise. It would not compile if we did not have operator plus equals there. Then the compiler does some wizardry so that if you do this, if you call plus equals, then P3 is this right here. It's the object that's being invoked. And then P1 is being passed as a parameter to that method right there. I didn't test it out to make sure.
Nope. Says no.
He says no.
Says no.
No operator.
There are build errors. Must return a value. Like what?
I don't return something in the bool operator.
Oh, I made it a bool.
That's what I was going to ask you, but then I...
Can I make it void? Is that going to be acceptable? Yeah. So now all 3 points are equal to 3, 4 because P3 started off at 0, 0, but we added one of the other points to it. Okay, so the change I had to add to get that is that plus equals does not return anything, unlike equal equal. Equal equal is a comparison. You know, if we were going to do less than, it also need to be defined as bool. Greater than, it need to be defined as bool. If you use addition, I'm not quite sure what it would have to do. I think it'd have to create a new point and then add the other 2 points together. I don't want to mess with that up. We're already kind of redlining our tachometer here, I think.
Remember you deleted your PowerPoint?
Yeah, I did. Now I kind of wish it was there already. Default constructors. The default constructor is what it gave us before we modified it. When we created it, it created a constructor that looked like this. Point, int. Nope. Like that. That's all that was in the code when we initially created it. Do you remember we had a constructor and a destructor, but they didn't have anything in it?
Yep.
That's okay. But now that we have added our own custom constructor, we can no longer do this. I cannot make a point P4 without providing any data for it, because we no longer have a constructor that matches. When you add your own custom constructor, the default constructor is no longer provided by the compiler. You can fix that in one of 2 ways. One is you could give these default values. You could say, oh, if you don't give me any values, I just want you to give an x and a y of a 0. That's probably the easiest. The other way is if you go back and give yourself the default constructor, even if that's just it. Now that'd be kind of dumb in this
So
case.
if you have your default constructor this way, and you have the other one that says your point takes it in x and y, what's your P4 going to actually be?
Well, if you invoke it like this, it's going to run that one. If you invoke it like this,
Yeah, that one. Just if you printed out P4, just next to all the other ones.
it should say 0, 0. And the reason for that is
And
that
default value.
the default value for any member of a class is 0 or null.
But they're uninitialized.
But they're not uninitialized because they're part of a class. Local variables inside functions do not get initialized with 0. Class members and global members do get initialized to 0.
Okay.
Why they made that differentiation, I don't know. I think everything ought to get initialized to 0 when you create it. But
that would make more sense, I think, than just
yeah,
oh, here's some random memory allocation.
Right.
Initialization.
yeah. So I don't know why they made that
Here's some
decision.
garbage. There you go.
Okay, but we run it, and ooh, I was so wrong. Look at that. I thought that x and y were going to be, ho. Didn't I read a slide, though, that said that they get initialized to null? I swear it
Doesn't
did.
matter if they're made public or private, that changes that.
No.
That would have anything to do with that.
Well, we can do that. Let's, just for grins. Okay, you were right. Me and my all-important blathering
No,
were
yeah, I
wrong.
was just like wondering, I had no idea. I
Yeah,
didn't know.
well, you were correct. I swear that I thought,
Probably just type in default and find it quick.
okay, take your advice.
Huh. Well, we did read a slide that did say that there.
Okay. What I just said about them being initialized to 0 is true for Java. It is not true for this language. We could fix that by doing that. Or we could go down here inside our default constructor and set them explicitly to 0. Like that. We have all sorts of possible solutions. Or we could do this, you know, x is equal to 0, y is equal to 0. Now when we run it, we should see it say 0, 0 for our fourth point. So overloaded constructors, a class can have more than one constructor. Right now we have 2 in ours if you made the same change I did, which is to have the default constructor and the non-default constructor. That's the change that I just made. I made a default constructor that sets x and y equal to 0, and we still have our our custom, our parameterized constructor. Overloaded constructors in a class must have different parameter lists. If you try to define 2 constructors that accept doubles, even if they have a different return type or the variables are named different, it just won't compile. Your methods, if you're trying to overload your methods, must have different parameter lists, prototypes, meaning that, you know, if you have 1 double, then the next one had better just be 1 int or better be 2 doubles or something. They cannot be identical. Only 1 default constructor and 1 destructor. Do not provide more than 1 default constructor for a class. If you make one that takes no arguments and one that has default arguments for all parameters, they're the same. Non-constructor member functions can also be overloaded. You want to set cost to a string? Sure, go for it. If you want to set cost to a double, no problem. They just have to have unique parameter lists. Cannot have identical prototypes. Using private member functions. You can make member functions, methods, private if you want. A private member function can only be called by another member function. You have to be in that class to get a hold of that member, just like you do with the private variables. It is used for internal processing by the class, stuff that you don't want to expose as part of the interface so that the client code can use it. See the create description function. I don't want to. Okay. Arrays of objects. Objects can be the elements of an array. The default constructor for the object is used when the array is defined. Let's make an array of points, just because we feel awesome like that. Point, I want 4 points.
Can we just put these points in an array?
AP for array of points. We could make an array of pointers and then set those points in them. We do not have an assignment operator. What would be cool is if we could do this. A, P, 0 is equal to P1. AP1,
Why can't we do that?
because we don't have an assignment operator. We have to
Let's create.
come over here and do operator equal. Hey, wait, now it's working though. Now it's not complaining.
Well, why wouldn't you be able to do that in the first place, though? I mean, that just seems like, because it's a point, and you're assigning a point to that location in a point array. So
But how does it copy it? What is it copying when we do that?
Oh,
In Java, it's easy because everything is a reference. So you're just copying a reference from here and here, but not everything's a reference in here. Not everything's a pointer. So I honestly don't know how that's working. But I'm going to see if it is. Let's print out AP0 and see if it equaled our point. Well, that's not going to work. We have to call print. Print AP0. AP sub 0. No, what am I doing? AP.print. There we go. AP sub 0 dot print. I'll get there. And we're not going to know what we're printing unless we do a C out in front of it. AP0 is equal to, like that. Yeah, it's equal to 3, 4. It did work. I'm slightly mystified as to why it worked. What if I just created a single point like this? Point P5 is equal to P0. P1, excuse me. It's not complaining. I thought we had to create an assignment operator, an operator equal, in order for that to work. It must be copying the X and the Y elements here. It must be providing us with a default assignment operator. Did not know that it did that. That's kind of cool though.
Beautiful. So let's go ahead and fill our array with our points.
Okay, I'm going to get rid of that. I want to go ahead and copy the other elements in. Cannot type. So now we have an array of 4. I really want to see how to override the arrow. But let's just do a for loop that'll print them out. For every point P in our array of points, let's call P.print. It should print out all 4 points again. I'm going to delete this AP0 print. Don't need that. Yeah, printed all the points out again. So then we could go and we could write a function that took a pointer to that array or a reference to that array. And, you know, it could process the array. Making it accept a reference to the array or a pointer to the array is far more efficient than copying the array into it, passing by copy in this language, because it would copy all the values. In Java, everything is a reference in a way, so it would not do that. I'm not strictly sure if that's true, but I think it is. All right, guys, we're going to do an experiment about passing arrays in as a function. Let's go up here above int main. Let's write a little function that sets the first element of an integer array to 0. So void set 0 is going to take an integer array, array of ints, AI, and we're going to set AI's first value, not 0, let's set it equal to something obvious, 256. I put the braces in the wrong place, so it's yelling at me. Is that going to fix it? Yeah. Okay. Now let's create an itty-bitty array. Int pi is equal to 3, 1, 4, 1, 5, 9. And then let's call set 0, passing in pi. And then let's see out the first element of the pi array and see if it is now equal to 256. Yeah, okay. I forgot that's because every array is actually a pointer. When you declare an array reference, an array in that syntax, pi is actually a pointer. And we saw that. If we wanted to, if we did this, cout star pi ENDL, it would print out 256. And if we did star cout parentheses pi plus 1, it would print out the 1. It would be the second element of the array. So in this language, an array variable and a pointer are the exact same thing. The syntax for using them is just different, but you can mix them. I guess that's worth making.
What was the difference between, did it print 256 twice?
Yeah, it did, because this and this are the same thing. The first element of the pi array
Why doesn't it set
is this.
zero? Why doesn't it set the first one to zero then? Oh, we had it set to
We were
256,
setting it
sorry.
equal to 256 in that call, right?
What were you saying about why both of those printed 256?
This is a pointer. Excuse me. This is an array reference. It's pointing.
That's the-
Trying to avoid using it. Like, say this is at memory address AAA.
Okay.
This, or PI, is at AAA. This syntax means print out the value at AAA
Okay.
with no modifications of it. That's what this is doing too. Those two syntaxes are identical to each other in meaning.
Doing that just prints out the first element. Of it
Exactly.
no matter what. Okay.
Right,
so
right.
if you change that to like pi 3, then that one would print out 4, or not 4, 1, and then that one would print out.
Yeah, we could, I'm going to copy, yeah, we want to print out the 4. That's plus 0, plus 1, plus 2. So we could do cout pi sub 2. That should get us the 4. But we could also cout star pi plus 2. It'll bump itself over to the third element. Like that.
So once.
I'm going to get rid of this medium one. Okay, there we go.
So once for if you know the position in the array, and then once for just if you. I guess you have to know the position for both of them. don't you?
Right. These get compiled to the exact same thing. The compiler is taking this. It's called syntactic sugar. Makes it sweeter to use. But underneath it all, it's doing this. That is that. And that gets converted to that. And you never see this in Java, because in Java, arrays are classes. They're not raw memory
'Cause when
positions.
they say it, they mean it, that's why.
Yeah,
Over here, we're over here saying a bunch of different stuff that means the same thing.
yeah.
Okay. I just.
I love trying to break y'all's mind by showing you two different things that are not true in the other languages you're learning.
But I mean, Dewey's not even going over the array list, so it's like, why?
Are you enrolled in Java 2 for the fall?
Mhm.
I got a email saying no one was enrolled in it. I need to double check that.
Let me double check.
All right. Arrays are really important. I don't mind recapping. If we're going to declare an array of ints, int, array name, and then you either put the size or you put an initializer list or both. You want an array of 4 ints, you can do that. If you want them all to be initialized to 0, you can do that. You want to set the first one equal to a value, you do that. You You want to set the second one equal to a value, you do that.
Can you just leave it uninitialized still?
No,
It's gotta have a value somewhere.
it'll give it out that garbage negative 8 billion value.
Okay.
Right. I'm going to change this to 3 because I don't feel like typing when 3 is the magic number. Okay. Or, so you can print them out like this, AN0, AN1, AN2. In C++, an array variable is actually a pointer. So you can do this. Cout star AN, and then star parentheses AN plus 1, star AN plus 2. And those two things will do identical things. This is the better syntax, obviously. If you'd never learned about pointers, I wouldn't be showing you this. So let's go ahead and remind ourselves how you declare a pointer. Say I have an int. No, say I have a double. It's called IQ. My IQ is very precise. My IQ is 234.7. Okay. Now, I want to pass that into a function called increase IQ. If I write a function called increase IQ that takes a double and adds 10 to it, great, but when I get back out here and print it out, what's it going to equal?
234.
Still going to equal what it did before.
So I know this is probably a weird question, but okay, so since you are adding 10, but you're adding 10 to its memory location, does that?
This isn't a pointer, it's nothing. It's a brand new variable that contains a copy of the value that was passed in.
Oh, okay.
So we have a brand new, a local variable, just like we declared it here.
Okay.
So a parameter is in effect a local variable that accepts a copy of the argument passed into it.
Okay. Sorry, never mind.
No, I mean, we're going to get to pointers, so we're going to write the same function now with a pointer so that we could actually increase it. We're going to call it P increase for pointer increase or whatever. So you declare a pointer like that. I like to preface all my pointers with a P to remind myself that it's a pointer. Peek. And when I want to reference it, I could write this in one statement, but I want it to be absolutely clear what's going on. I'm going to declare a new variable that contains the value. So at this point it equals 234. This is bugging me. I don't think this is going to work.
Should be a double.
Yeah, it should be a double. I'm just going to have to do this. PIQ plus equals 10. Like that.
Well, what you're going to do, you're just going to store it in X and then still increment it or increase it. So we understand what you're going to do.
Yeah, here's what I was going to do. I was going to do double X is equal to the value stored at that position, and then I was going to add 10 to it, X plus equals 10, and then I was going to say that memory value is now equal to X, like that. And when we're done with it, PIQ has been increased by 10.
Do you need that 35?
Yes, because these are not pointing to the same thing. This is when you put the star in front of the pointer, it actually goes to that memory address and gets the value out. Opens the mailbox, pulls the data out. It's not manipulating the address at a mailbox, it's getting the mail out of it. I know my similes are stupid, but my metaphors. So what this is doing is this is saying that we have a memory address, AAAAA, but no, I want what's contained in AAAAA. So 234 gets stored into X. And then we add 10 to it, and now it's 244. and now we're copying it back into the memory that's stored at that position.
Okay, so if you printed out double X in that function, or X, that one would equal 244, but.
They both would equal, well, 244 at this point.
Before you did that statement.
Yeah, if I did this,
Okay,
that's gonna be 244.8.
and then,
If I did this one,
okay.
star PIQ, at this point, it's still equal to 234.8 because I haven't stored anything new into its memory.
Gotcha.
And then after that one, and see how it'll be the 244.
Exactly, exactly. See out, peak now would be 244.8.
And if you see out anytime after you call that function, that'll be the 244 also.
Right, if I come down here and call P increase, and I pass in, I can't just pass in IQ, because that's a double, it's not a pointer to a double, so I need to do the ampersand, that means send in the address of it. Man, I think pointers are nasty syntax.
Send in the pointer or the reference?
That's not a reference, even though it's defined with an ampersand, that means address of. Read it like that, address of. And then they stole the same syntax to define references. So we're gonna make one called R increase for references. That one is as easy as the first one was, except it's not star IQ, it's just, there we go, like that. We're back to being able to do this. That's all we have to do.
Well, then I'm just gonna use reference.
You're just gonna use references from now on. That's a totally legit decision to make, I swear. Once I learned about references, or once I moved from C to C++, I stopped using pointers unless it was absolutely necessary.
When, in what, I guess, situation would you have to use a pointer?
Seriously.
Seriously.
If you're moving around chunks of memory, then you might have pointers to pointers. Why don't we Google up why use pointers?
Instead.
Why use C++ pointers than references?
Maybe some-
When to use references plus versus pointers?
It's just gonna be like some old person talking about C code, just regular C code, and then they'll be like, well, it's because it's the proper syntax or something stupid.
It comes
like that.
down to personal preference. I've accepted the answer below that references Google C++ style guide. They say references can be confusing, as they have value syntax but pointer semantics. No, they don't.
See what it says right above that? It says edit, outdated. That means the old person wrote that.
It seems like you've made your decision already about which one to use when. Personally, I prefer to pass in the object that I'm working on. If a function takes a pointer, that tells me that it's acting on the pointers.
An example, you use them as iterations in the array.
Due to the additional work required to sanitize pointer arguments, it makes sense from a maintainability perspective to use references when an object must be present. Although it's a shame to lose the syntactic clarity. Now, I think that the references are clear. I'm not coming up with a real good answer. I honestly swear that once I moved from...
We can avoid them at all costs and just go with references.
Yeah.
Use
Yeah,
references
once I moved from C to C++, I never used pointers again. That's just really the truth of it.
That guy says avoid pointers until you can't.
Yeah. I like this comment. This Google C++ style guide is not considered a good style guide. It's a style guide for working with Google's old C++ base. Accepting an answer based on that is not helping anyone. Okay, here we go.
I mean,
Use references whenever you can, pointers whenever you must. Avoid pointers until you can't. I like that. The old rule of thumb is to use pointers only if there's no other choice. For example, returning a pointer to an object is a valid option if the function can return null pointer. Okay, that's a good point. That's a very good point. What if you have a function that is supposed to create an object, but you're not sure it's going to create the object or not? What if we had a, let's go back to our code. This is actually totally legit use for pointers.
let's say like we have a.
We're going
group
to
that
make a
creates
function that creates a new point. I'm just going to call it make point. And so it makes a new point. And returns it. That's great and all, but how would you pass back an error? How would you tell the calling code that something went wrong and I wasn't able to make my point? I wasn't able to open a file, or I ran out of memory, or something like that.
Make that a method, wouldn't we?
Well, you could print out a message, but
No, we'd put a method in our header file, right? Could we?
well, we could make this make point part of the pointer.h class. But down here, when we're creating points, pointer new p is equal to make point, we have no way of passing back the fact that this may have failed. And right now, of course, this is not going to fail, but what if making a point was an expensive process? It had to open a database and read some values in, and if the database was not, So what you want to be able to do is do something like this. Point p is equal to make point, and then if new p is equal to null, then go oopsie. Couldn't make it. Like that. And in order to use that syntax, you actually have to use a pointer. So you would do this. Make me a new point, and then return the address of that. But if something went wrong, return null instead. And now down here, we're going to create a pointer to it. And if p new is equal to null, we know it's a bad thing, that it didn't work, and we better not use it. That's a totally legit reason for using pointers.
Okay, so if you create, okay, so we say if we, before you made all those changes and you had your make point, and it didn't create it, and you tried to see out that point, would it print, what would it print? The memory address that was allocated for it, even though there's
It
not,
just wouldn't
it
work.
wouldn't work at all? Okay.
Yeah. We don't have any facility in here for it failing, There's nothing in here that would cause it to fail. But if it was going to fail, how would we indicate that? Would we just make a point that was equal to 0, 0 instead and pass that back?
Yeah, that's
Well, if you're dealing with with data with no room for errors, I don't think you would want to pass
yeah,
that.
you would want to pass that.
Right.
error message.
So what you could do is, like in the fstream class, there's that .good feature where you check to see if the file is good by calling .good. So we could say, pointer is equal to make pointer, and then you could say if, or not pointer is equal to, get point, and then if the point.good, then you have good data. That's how they handled that in the file class.
Make point a bool?
Yeah, but if you make it a bool, then you're not returning the object.
You can't return the pointer that you're trying to pass in or trying to get from.
Very good point. You could do this. No, I'm not going to talk about that. You'd have to use a pointer to a pointer to get that to work, and that's
But
getting
you
even
could-
worse.
You could make it a bool and do that, though? Or
No.
More complicated?
Okay, you could do this. Bool ampersand be okay. And if it works right, then you set be okay equal to true. If it fails, you set be okay equal to false. And down here, when you call make point, you pass in, bool, did it work? Like that. And then you could check, did it work? But you were suggesting the opposite, that you return the bool. So you could pass something in.
Yeah. if
That
it's-
totally works.
No, yeah, that's, okay.
Yeah, either one would work. That's why it's good to have more than one tactic. The ability to return an error code and also get, some good data back through a reference or through a pointer is a very good thing. I feel like deleting all that now. I'm going to undo those changes.
I just get confused when I see, like, you use a pointer So I'm just, I don't know why you didn't do, I don't, why that wasn't just. a-
Yeah, whenever you see the and, replace that with, in
Address.
your mind with the address of.
Okay, well, I guess I get confused when you use a pointer and the address of. Why wouldn't you just do address of make point and then return address of make point?
Because we don't care about the address of the make point function.
Oh, okay.
Instead, we're saying that we want a pointer. This star here is actually part of that, like
Oh.
that.
Gotcha.
Hope that helps.
It does.
Okay.
Lots and lots of error code.
All right, so you can use an initializer list to invoke a constructor that takes arguments. If we wanted to pass some arguments in to a constructor that took strings, that's what you can do. Here they've written some kind of a class called inventory item that has a constructor that accepts one string. And so they're creating an array of strings that would create 3 different inventory items. I don't know how to use that to pass in more than one piece of data because we were requiring X and Y, you know. How would we create an array of points that took X and Y pairs?
2D, right?
Maybe you could do that. Maybe it'd look like this, which is what a 2D array looks like. Don't know. Oh, here they're going to tell us. If the constructor requires more than one argument, the initializer must take the form of a function call. Inventory 3 looks like this. Inventory item. Okay, you create one item there, another item there, and another item there.
Dang, those are some cheap hammers.
That's kind of bizarre. So here we go. We're going to do that. Point. Here's a new array. More points. And it's equal to point 5 comma negative 5 point 4 comma 4 and point negative 800 comma 800. So now we have another array. This one is an array of 3 points initialized to those 3 values. If we wanted another for loop to print them out, we could. For point. For every point in the more points array, print it out. Yeah, p dot print. It'd be kind of nifty if we were giving the points names as we created them so that when we printed them out, we'd know which point we were using. You know? This one's Fred, this one's Barney, this one's Bugs. When we created them, we would do this. Hi, that's Bugs' point, you know. But we don't have a constructor that accepts a string as a first argument. We could go and overload the constructor so that it did accept a name as a first argument. It isn't necessary to call the same constructor for each object in the array.
So you can just say point.
So here, that calls the constructor that accepts one argument. That's confusing me. If you're going to do this, then you may as well do it every time, in my opinion. I would modify that so that it called inventory item parentheses hammer and inventory item wrench 8.7520 and then another one that said inventory item pliers. Mixing your syntax like that is just too clever by half. Accessing the objects in the array, we know how to do that. Just like that. But since it's got methods, we could do that. So if we wanted to print out our items, more points element 0 dot print, like that. That would print out that point. Yeah. The way I feel about it is that I want you to understand everything that we've done really well except for pointers. If that's still hazy in your mind, that's okay. If you go back and become a professional C++ programmer, you better nail it down good. But the concept is so alien to the other programming languages that you're going to use that it's okay to walk away, not, not having it firmly tucked in your pocket. Okay, unified modeling language. Let's see what they have to say about that. I've already shown you my version of a unified modeling language. UML stands for Unified Modeling Language. Do we have the recorder going? I'm nervous now. Yeah, okay. Provides a set of standard diagrams for graphically depicting object-oriented systems. And it's actually a lot more complicated than what I showed you, because it can show you when you have objects inside of objects, which we haven't talked about. If I went back, remember I was talking about giving these objects names? I'm going to add something to my point class that's a name. String name. I'm just going to give it a default value. There. And I could do something with that. But string is actually its own class. So now I have a class that's inside another class. And then if I wanted to, what is a line? A line is defined as 2 points, right? No, well, that's a segment anyways. Anyways, you define 2 points. That defines a line. You could create a line class that had point 1 in it and point 2.
Well, in this instance, are you not using the raw data type because we don't have include string?
You're right. It would be using the C character array if we did that.
Gotcha.
I really wish they had not done that.
At least capitalize the S like that.
They should have capitalized the other one, like they did in Java, to indicate that it's a class. But C++ came before that little rule about always capitalizing your classes came about. So here's how it looks. The class name goes in the first box. Then you list all your member variables, attributes, and then you list your member functions, methods, there. Here's our rectangle. Width and length. Set width, set length, get length, and then get area. Let's go back to our code here and make the things constant that ought to should be constant. Does plus equal change the values of x or y?
No. Wait, yep.
Yeah.
It does, so we can't make that a const. If we made that a const, that would be bad because we couldn't change the values of it. How about equal equal?
No.
It does not change the values of x and y, so it should officially be declared as a constant method. That way you could check to see if 2 points were equal, even if one of them or both of them are constants.
They do.
Yeah, when you print it, you're not changing its value. Distance 2 does not change its data, so we should declare it as a constant. Print does not change its data, so we should declare it as a constant.
We did go over that, making our access methods constants.
Now, constructors are clearly not constants because they exist only to change, data in it. So we're not going to make those constant. Now it's going to get a little bit worse. We haven't been using constant parameters, but is plus equal supposed to change the value of the argument that's passed into it?
No.
It's not supposed to, so we would make that a constant. How about equal equal? When you compare two things, are you changing the value of either of them? Nope, so you would put const there. Same for distance 2. Distance 2 does not change the value of the point being passed in. That made the syntax harder to read. That's why I left it out. When I copied and pasted it from the other page, it looked like that actually. And then I very quickly went and deleted the words const to make the syntax clearer. But that did not break the code. Let's create over here in main a constant point. Heck, come back. I don't know what I just did. There we go. So that's what we did. We added const there, we added const there, we added const there, and we added const there. Now let's create a constant point. Constant CP for constant point is at 1, 1. I didn't declare what data type it was. There we go. I can print it out, just great. Can I add another point to it? Can I do CP plus equals my old point 1? No, I cannot, because CP is defined as a constant, so I cannot use a non-constant method. and the plus equals operator is a non-constant method. So it forbids me from doing that.
Since, well,
It says error, no operator matches these operands. And then it says operand types are constant point. It's wanting this to be a constant. No, it's wanting this one to be a constant. But it's not.
And just name it a constant right above it.
no, you meant,
I'm saying it backwards.
yeah, you meant the other point.
Since,
Point is supposed to be-
since this method plus equal is not defined as being constant,
Oh, there you go.
if I do that, that's great, but now this one should not compile because these have to be modifiable values. So there's just no way I can get that to work. And that's appropriate. If I make a constant, I don't want to then be adding things to it. You put minus signs in front of the variables or the methods that are private. You put pluses inside of the ones that are public. I hope I did that. Did I put the pluses on the
Yeah, you
on the
did.
homework? Okay, good.
On the work.
Yeah.
Words.
To indicate the data type of a member variable, you follow it with a colon and then the data type. When you're creating parameters and you want to list the parameters that that function takes, if you're doing it in UML, you put a colon and you follow it by the data type. Which is just exactly backwards of how we define it in C and every other language I've seen, but okay. UML is its own thing.
So what is the UML necessarily for? Is this just like something that companies would give you like, hey, we need these classes or something?
Right. It's supposed to, it's not for any language in particular. It's cross-language, just like flowcharts. You know, you can write a flowchart and then you can give it to your...
It's more of like an industrial thing that's going to be happening that you'll see here.
Yeah, so you can give it to a programmer familiar in any language and then they could implement in their language of choice.
Okay.
So you're specifying a process of some kind, but you're not specifying how it's implemented. So you can draw the UML in the flowchart and give it to them and then they'll know how to do it. We are done with UML. They show the constructor. Here's the constructor for the inventory item that takes a character array, a substitute for a string. And then they have another constructor that takes a string followed by a double followed by an int. And we're just supposed to know that C means cost and U means units. I really prefer to actually use good parameter names so that when I'm looking at it, I know what the second thing is that I'm passing and the third thing is. And that's when you have to use this reference to get it to handle it. Oh boy, we have hit the end of the class. What are we going to do? We went way faster than my last summer class did, probably because there's fewer people in it. We had like 18 people in the summer last semester.
It's because we're studs.
Yeah.
Actually, I had a question about,
Yeah.
pick your brain about it. It was for the dice roll project, the like extra credit one that we were doing.
Sure.
I pretty much have it done. I'm just like, I was gonna put it out in like a histograph, but I'm kind of having problems getting it to do what I want.
Okay.
Necessarily.
I need to go refresh my own brain.
Okay.
The stereotypical phrases. I've slept since then. Let me go.
It was like, do a dice roll for 2 dice, add and then like.
Oh, and then we're
it
going
was
to...
the frequency. For
the
like
frequency
100
table.
rolls.
Right.
Yeah.
Oh, by the way, there's a quiz now out there for functions. Chapter 6 quiz. Which wasn't there before, so you're going to want to go and do that. By Monday, I will have the quiz for classes for the last chapter we did uploaded, and then our final is going to be the Monday after that. So I have to think of something really cool for us to do on Monday and Wednesday, because we've covered all the material that I wanted to cover. Let's do sorting after we talk about your question.
Here's a project ideas one.
Why do I have two Word documents? I bet one of them was supposed to be a PDF, and instead I just uploaded the same one twice.
I thought that today when I looked at that. I was like, oh.
Okay. Project idea. Dice frequency table. Write a program that generates two random numbers representing dice, adding them together. Do this 100 times so that you can keep track of how many times a 2 was rolled, a 3 was rolled, and so on. Then print out the frequency table. Okay, so
I think I'm just having like problems with my for-loop for the printout. I think that I have most of it initialized into an array, but I'm not quite sure.
let's write a really simple version. This will be good enough to take us to the end of today. A really simple version that just keeps track of like 3 things.
Can you leave, my Visual Studio is doing something where I can't edit anything, it just deletes everything in front of typing, and I can't get it to stop.
Let's hit insert.
Hit the insert key.
Yeah.
You see the key above the delete key and next to the home key? Press insert.
What happened last night? I quit on the video, let it know what was going on.
Okay.
That fixed it.
Isn't that annoying?
Right?
When do you ever want it to do that? Okay, so let's make a new project, and this one's going to be very similar to that dice frequency table. So create a brand new project. And this is dealing with arrays, which is an incredibly important topic, so it really is well worth the additional time we're going to speak. And I should have taken a break so that we could use bathroom. All right, 5 minutes, y'all. We'll come back in 5 minutes. Yeah, something about the multiplying is not getting right. Okay, so we're going to start off with this boilerplate, and what we're going to do is we just want an itty-bitty array that's going to count numbers 1, 2, 3, or 4. We're going to ask our favorite number, and if they like the number 1, we're going to put 1 in. And if they like the number 2, we're going to put the number 2 there, and so on. So we need an array that'll allow us to store numbers 1, 2, 3, 4. Now we could declare the array to exactly 4, or we could declare it in such a size that we could reference it by 1, 2, and 3, 4, but that's going to leave us skipping element 0. I'd rather make it 5 so that we could choose 1, 2, 3, and 4 and just leave space 0 out. Okay, so now let's put a while loop in. While true, cout, enter your fave number 1 through 4, or -1 to quit. Now we need that choice. Int choice, read that in, CIN into choice. And nope, we already have a variable called choice. Sorry. Let's call it fave. Int fave, because that's their favorite number. And so choice, at that specific value that they chose, gets increased by 1. And it keeps doing that until they're tired of it. Now, were you trying to print your array out, your data out like as a series of asterisks or something to make a bar graph? Okay, so we'll do that. Now let's step through the array. I is less than the length of the array, which is 5. I should not be hard coding this. But I don't want to start at 0 because we never use 0. We just ask them for 1, 2, 3, or 4. So I actually want to start it off at 1.
So for like, if it's dice roll, we can
What?
start at 2 then, right?
Right, exactly. Right. Okay, so then int, the number of dots we're going to print is equal to the choice at that specific part of the array. And then we're going to write a little loop. For int, x is equal to 0, x is less than the number of dots to print, x plus plus, and we're going to cout an asterisk each time. After we're done with that line, we're going to cout a character turn. I want to add one more cout. Above our for loop, I want to print out the number itself that we're printing. And I would like for this to be in the while loop. So bear with me, cut that guy, and paste it inside the while loop. I'll go back to it.
No, we didn't put it -1 if.
Oh, we never put in a -1. Okay. Well, then we're corrupting memory while we do that. Ooh, and this type of minus sign, it goes nuts. Okay, anyways.
That was the kind of thing I got with mine, except it was just the asterisks.
Yeah, okay. So,
So if
right there, after we enter fave, if fave is less than 0, break. Just get us out of the loop.
What if their favorite number is negative?
Well, too bad. We told them to pick 1 through 4.
Can we do if they equals -1?
Uh-huh. Yeah, yeah. What I'd like to do is if fave is less than 0 or fave is greater than 4, because those are our values, you know, that are acceptable. And if it's outside the range, too bad. We're just quitting the loop. We're calling them stupid and we're bailing. But if you want to make it equal -1, that's fine. In fact, I'll do that because that's what we told them to type. Okay. So now you have your little histogram.
Only this one star left.
Well, keep typing numbers.
Oh, wait. Oh, okay.
I started typing in 5, so I was corrupting memory somewhere. I wonder.
Oh, yeah, I did that too.
See, we ought to be checking our data before we use it in the array. Right here, we should use an if statement to qualify it before we start just messing with the array at that point.
Oh,
That-
this is what... We
It-
can make a little game out of this.
Yeah. So I'm putting this array inside a class and then validating the data each time you pass in a favorite number wouldn't be a bad idea.
What's it mean, exception thrown?
Mine changed whenever I put a system pause at the bottom. I don't know if that.
What do you mean
was the
changed?
case. Whenever I didn't have a system pause at the bottom, it threw an exception for some odd reason. I don't know why, but it stopped when I.
Well, if you type in an invalid value like 5 or something, okay, we're going to do this properly. If fav is less than 1 or fav is greater than 4, because those are invalid values, cout invalid value /n, else add 1 to choice, like that. That'll make it more bulletproof. I don't know why that's so fun. I find that charming to do, sitting there and typing those and having that increase.
You're right.
Letter in it does something crazy.
Pardon me?
It's really crazy.
Oh, snap, I broke it.
Yeah.
What happened? What'd you do?
You put a letter in it.
Oh, yeah, that'd break it. What you really ought to do is read in everything as a string and then convert it into an integer or whatever for safety's sake, because then you can validate your data in the most, thorough way possible. So, say you had a series of numbers. People watching the lecture aren't going to be able to see this. We've already evaluated that this does not work,
You have a green one.
but we have a green one. Maybe he works.
Right next to you.
Okay. We define our array. It's not much better.
You read them.
Okay. We define our array of Ginny, who's equal to 8, 6, 7, 5, 3, 0, 9. But you really want those values to be placed in ascending order. No, I didn't want this up. No, I don't know what I want. Okay.
0, 3, 5, 6, 7,
Right.
8, 9.
So how would you write an algorithm to do that? There are two classical ones that are taught in intro programming classes. One is called the bubble sort, and one is called the selection sort.
I thought you were gonna actually,
So we have bubble sort and selection sort. The way selection sort does, it's the easiest to explain, is it starts at the beginning and then it runs through the entire one looking for the lowest value. Okay? So 8, 8's my current value. 6, is 6 higher than 8? No. Is 7 higher than 8? Wait, I'm looking for lower. Is 6 lower than 8? It
Yeah.
sure is. So now
The new
we
value
have
is
to store 6 here. Is 7 lower than 6? No. Is 5 lower than 6? Yes. So now we store 5. Is 3 lower than 6? Yes. Is 0 lower than 3? Yes. So now we store a 0 there. A 9? Okay, now we search the entire string. We found the position of the lowest value. And then we swap them. So we put a 0 here and an 8 here. Now you don't deal with this one anymore, so your for loop starts with 1 instead of 0. 6 is my lowest value. Is 7 lower? Nope. Is 5 lower? Yes. Is 3 lower? Yes. There's an 8 there now, after we swapped it. Let's, that's after one run. The second run, we're looking for the lowest number, and we're going to put it there. What's the lowest number now? Skipping that first one, it's a 3. So we would swap those. Okay, now what about 7? We're going to search this and find the lowest number and swap it into the 7.
5.
It's 5. And you can imagine how it's going. You know, you're using a for loop to find the lowest number.
But would you have two different counters, or would you have like a nested for count?
You got to keep 2 counters. One is your current position, and one is the position that you're inspecting and will eventually swap with.
So would it be like a nested loop then, or?
Yeah, yeah, it's going to be a nested loop. Let's see if we can write it. The bubble sort kind of works a little bit differently. What you do is you compare the first 2 values. Is 6 lower than 8? Yeah, it sure is. So swap it. Is 8 lower than 7? It sure is. So swap it. Is 8 less than 5? Yeah, it sure is. So swap them. Is 8 less than 3? It sure is. So swap them. Is 8 less than 0? It sure is. So swap them. Is 8 less than 9? No, it is not. So 9 is in its proper place now. Then you repeat the process.
That's the bubble sort?
This is the bubble sort. Right. And so now you do that again. Is 6 less than 7? It is. So keep it there. Is 7 less than 5? Nope, we got to swap them. So now 6, 5, and we're pushing the 7 along. Is 7 less than the 3? Yeah, so put the 3 there. We'll keep pushing the 7 up. Is
So both
7...
of these go in ascending order. Or you can make it go in whatever order you want it to go.
Right, you could do it in either ascending or descending order. So now we know that those 2 are in the correct place. And you just keep repeating that until you've done the whole thing. Until you've pushed all the highest numbers off to the end. That's why it's called the bubble sort. They're kind of bubbling to the end. Or if you're doing it the other way and you're looking for the lowest numbers are bubbling up. Okay, so we had our favorite dots. Let's go ahead and put Jenny's phone number in now. Int Jenny is equal to 8675309. And we know that phone numbers are a length of 7, so I'm just going to declare a constant, which is the length of Jenny is 7. So I can use my for loop. Now it's going to be a nested for loop. You saw this process of where we're keeping track of this counter, you know, that position.
Could you use a range base as your outermost?
Range-based for loops do not work when you're changing the data because you get a copy of it. So we're going to need a counter. That's the current position, and then that's the swap position. So I'm going to call my counter C, and then my swap position is going to be S. So for int C is equal to 0, C is less than the length of J, C++, that's our outer loop. And then now we want an inner loop that starts at C. It actually starts one past C, right? Because we don't want to compare C against itself. So for int, the swap position is equal to c plus 1. C is less than the length. Don't know what I did there. C is less than the length of the J array. C plus, no. S is less than the length of the array, and then S plus plus. And now we need to check if the one value is greater than the other. So if the J array at position C, the first one, is greater than the one that we want to swap with, then we need to take note of that. Swap is equal to S. We don't have a swap counter yet, so we need to create one. Let's do that here. Int swap, or swap position, we're going to just set it equal to -1. But if we find a good value, then we're going to assign it. I don't think that's going to work. I think that I botched it. Maybe I don't actually need to code it. Maybe that explanation was enough. Why don't I go Google up selection sort in C++? Selection sort C++, and go and find the algorithm. All right, they wrote a function called swap, which swaps two positions. But they have a nested loop, just like we did, starting at 0 and going up to the length of the array -1. That's their outer loop. And then they have a minimum index counter, which is equal to that one, and they have an inner loop that starts at their outer loop +1, going up to n. And then if the value at that one is less than the value at the minimum index, then the new minimum index is what we're looking at. I was very close. Let's go back and take a stab at it. Yeah, we would use greater than. We were sorting them in that order. As long as we're consistent, it's going to be okay. I'm going to rename this one a little bit to minimum I, short for index. No, I'm going to set it equal to C. Why? I'm just going to set it equal to the first value in it, you know. And so, if the position that we're looking at, I'm going to steal their code. I want to get it right. If the value that we're looking back is greater than, I'm going to follow it exactly, is less than the value at that minimum position, then we're going to set that equal to it. So let's do that. If the value that we're currently looking at, which is S, is less than the value at that minimum index, then that means that needs to be our new minimum index. And then by the time we get down here, we need to swap those two. How do you do a swap? It's a three-step process if you think about it. You have two elements in the array, you know, that don't write this. But say you have elements 0 and 2. How do you swap those? You can't just do A0 is equal to A2 because that loses A0
Store A0
in a temporary variable. That's what we're going to have to do.
that temporary variable.
Right. So now let's swap those two values. Swap J at S and J at the minimum position. We ought to check to see if they're the same, but I'm going to ignore that. So int temporary is equal to J at position S. J at S is now equal to that J at that minimum value. Minimum index. She's yelling at me about S. I guess it's really supposed to be C, isn't it? Because of that. Go with that. And then J at min 1 is equal to temp, or min I is equal to temp. Now we have swapped those two values. And then let's print out our array. This is just so we can watch it change through each iteration. For every V in the Jenny array, we're going to see out V followed by a space. And then after the loop, we're going to print an end line. All right, there's some possibility this is actually going to work. And we're not going to implement the bubble sort. This is going to be the last thing we do today. All right, I don't want to enter favorite numbers anymore. I didn't print out the array to begin with. I'm going to copy this print code and paste it to right underneath the declaration of the array. You see what I did? I just took that for loop that prints the array out, and I put it right underneath where I define the array. Can't quite get it all on the screen at the same time unless I, did some removing of braces.
Oh, you still need that for loop down at the bottom too, though.
Yes, I didn't. If I said cut, I didn't mean
No, that was.
cut. Yeah. So I do need that one. So the first lowest value gets copied into the first position. That's what happens the first iteration. Then it goes and it finds the next lowest value and copies it into the second position. Then it goes and finds the third lowest value and puts it in the third position. The fourth lowest value goes there. The fifth lowest value. Notice that it's already, by the time we get to here, it's already fixed,
But it
You,
keeps going.
you could put a check in there if no swaps were necessary, then bail, We didn't find anything, so we could just stop. But so you could optimize it a little bit. But that's a selection sort. A bubble sort is where you compare two elements, and if one is larger than the other one, you swap it. And you keep doing that until you get to the end, and then you start over, and you repeat that, and you keep repeating it. I don't want to code that one, so why don't we stop there? You don't have to memorize this, but I want you to have the idea of what a selection sort is. Are there libraries now that implement all these things? Yes, of course there are. In the real world, you're not going to have to sit down and write your own sorting algorithm, and there are a lot of them. Selection sort and bubble sort are by far not super duper efficient. There are much more efficient ones, but they're far more complicated to understand. Some of them use recursion, when you're calling your own function. Have we talked about recursion?
Yep.
Okay.
That's not
All right, let's make a Dropbox for what we've done. M. We did the point class. We didn't get around to doing the other one that I was talking about, but I think we pretty much have the idea. Operator overloading. If you want to upload the other things that we did as well, that's totally cool. We did the little frequency table. If you want to put that in there, that's fine. If you want to put the selection sort that we did, that's fine. But I absolutely do want you to put the point class in there. And I put it in homework rather than in class. Alright, I saw something weird. I made the sphere classes do the 18, which is not correct, is it? We'll make those due a week from today, 25th. All right, I'm not coming up with much cool to do with classes that we haven't already talked about? Number 12 is just going to be to modify your sphere class to have an equal operator and an addition operator, just like our point classes did. And what do you do when you add two spheres together? You just add their radiuses together. Is that realistic? No, you ought to be checking their volumes, add their volumes together, and then calculate a new radius, but that's okay. So our homework will be, oh, that won't work if you did the T assignment. I'm just going to hope that y'all have the idea of operator overloading, and we're going to leave it at that, okay? So no homework based on that, and I will see y'all on Monday.